Okay, this entire spreadsheet or worksheet could be used for systems of equations graphing, or it could be used for systems of equations substitution. We're going to use it for substitution, but just by looking at it, notice that each of these are in slope-intercept form. These are perfectly designed to be graphed, so you could graph each of these, and that would be fine. Or you could use some substitution, and that would be fine. And really, after today, it's going to be your choice, whichever one you want to use. But today I want you to practice solving substitution, so I want you to do them all using substitution, which is what the directions say. Okay. These types are actually pretty simple. I don't think you're going to have any issues. We're just going to do 2 of them together, and then the rest of them you're going to do by yourself. And you can even graph them to check yourself when you're done. You can go out to Desmos and you can graph them and you can see whether you're right or wrong. So if you remember from the first video, anytime that they're both equal to y, they can be set up to be equal to each other. And so you just, oops, not pi, it looks like pi. You can just set them up and set them equal to each other. And this now is an equation with variables on both sides. And the rule of thumb is that you always move the smaller x. You don't have to, but if you do, you will make it easier on yourself because you won't have negative numbers or negative x's. And then you subtract 1 from both sides and you get that x is 1. Now that you know that x is 1, now you're going to use it to plug back in for one of the equations to find out what y is. And so I'm going to write x is 1 up here, and I'm going to erase, because we're done solving for x. Now we're going to solve for y. I'm going to use that first one because it looks very simple. So it says y equals x plus 2, and what I know is that x is 1. So y equals 1 plus 2, which is 3. So y equals 3. And now the first one's done. So to recap, I set both of the equations equal to each other. I solved for one of the variables, x, and then I used x to find out what y is. And that's the same process over and over and over again. So take some notes. Step 1, set the equations equal to each other. Step 2, solve for x. Step 3, plug x back in for one of the equations and solve for y. And you're done. So let's do number 2. I'm going to erase this just so we don't confuse ourselves. And again, all we're doing is setting the 2 equations equal to each other. Because if they're both equal to if they're both equal to y, then they're equal to each other. And 2x is the smaller x here, so we're going to subtract it. If you forget how to solve for equations with variables on both sides, just go ahead and go back and watch video. There's videos in the same, previously we've done this before. So go back and watch the videos again. It shouldn't take very long to get reacquainted. So x is 3. So this is what we know. X equals 3. And so now I'm going to pick one of the equations. They both look about the same difficulty, so it doesn't really matter. I'll just pick the second one. So I got y equals 3x plus 4. And so y equals 3 times plus 4, and then y equals, 3 times 3 is 9. Plus 4, so y equals 13. And that's what you're going to do every time. So I want you to do the rest of the page. And again, always check yourself with Desmos. And I'll show you, just in case you forget, how to do that. Okay, so I went out to Desmos and I graphed the first equation, and sure enough, they cross over at 1, 3. So we were right about that. And the second equation, systems of equation, crossed over at 3:13. So we were right about that. So you can always check yourself. You can solve them and go out and graph them and make sure that you're right. Like, there's no reason to get a wrong answer here. There's no reason to get upset. Just, if you get it wrong, just start over, try to figure it out.